This is the predicted paper that I've written for paper 1 higher, your non-calculator paper on the 15th of May 2025. It is a predicted paper in that I've just looked at topics that come up lots and I've put them all together, had a go at writing the questions, and I hope you guys enjoy it, and it should be a really good way of preparing you for the non-calculator paper. So let's get into it. Question number 1, work out 7.18 multiplied by 3.6 divided by 1.2. Now, if this was an estimate question, we would be able to round these numbers, but I'm not told to estimate here, I'm told to just work out. So we're just going to do this, and I'm going to do 718 multiplied by 36. I'm going to multiply these, I'm not going to worry about the decimal point till after. 6 times 8 is 48. 6 times 1 is 6, add the 4 is 10, and 6 times 7 is 42, add the 1 is 43. Then pop our 0 in because we're moving over to the 3, but really it's 30. 3 times 8 is 24, so 4 carry the 2. 3 times 1 is 3, add the 2 is 5, and 3 times 7 is 21. Adding that down, I've got 8, 4, 8, 5, and 2. So 2, 5, 8, 4, 8. We could see that the question was 7 times 4, roughly. And we know that 7 times 4 is 28. So I'm happy if the answer is 25.848. I think that makes sense. We now need to divide that by 1.2. And to divide by 1.2 is a little bit tricky. So what I always do is write it as a fraction and make that denominator 12. So this is going to be 258.48 divided by 12. And now we can use our bus stop method. 258.48. How many 12s go into 2? 0. So we haven't used either of those 2 up, so carry it over. 12 into 25 goes twice, remainder 1. 12 into 18 goes once, remainder 6. 12 into 64 goes 5 times, that's 60, remainder 4. And 12 into 48 goes 4 times. So our answer for that one is 21.54. Question number 2, and we are told that the universal set is all the odd numbers less than 16. So that is all the numbers you know about in the universe right now. 1, 3, 5, 7, 9, 11, 13, and 15. That is your universal set. Now set A is the numbers 1, 3, 7, 9, and 15, and set B is all our prime numbers. Prime numbers are numbers with only 2 factors, 1 and itself, and so we need to make sure that only the prime numbers are going in the circle that is B. In the middle, let's list them. So 1 is not a prime number, 3 is a prime number, 5 is a prime number, 7's prime, 11 is prime, and 13 is prime of those numbers up there. 17 is also a prime number, but since 17 is not in our universal set, we're not going to include it for this question. Now in the intersection, we can see that we can put 3, because that's in both A and B. We can also put 7, because that's in both A and B, and that's it. So 3 and 7 are going in the intersection. I've got 1, 9, and 15 left outside in our A circle, and I've got 5, 11, and 13 in that circle. Now I just need to make sure that all numbers are included in A or B. So I've got 1, 3, 5, 7, 9, 11, 13, 15. Yes, I have. So all of the numbers are there. In this example, there were no numbers left to go on the outside, but you need to make sure if you do have numbers left over, that they go on the outside as well. We are then told that a number is chosen at random from the universal set, and we're asked to find the probability that the number chosen is in the set A union B. Now, what I will normally say to you guys is this guy is the intersection. He's very, very picky, and is only going to pick it up if it's in the middle. So this is the way I remember these things. You've got your 2 circles. If you're asked for the probability of A intersection B, you need to think of it like that way up. It's only going to come down and pick it up if it's in the middle. If you're asked A union B, then as long as it's in the buckets, you can scoop them all in. So imagine it's like that, and anything from either of the circles can go into that bucket. So A union B, which is what we're asked here. What is the probability of me taking a number from A union B? Well, actually, all of our numbers are in A union B, and therefore the probability would just be 1. You could say, what have we got? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 8 if you wanted to, that would be absolutely fine. But our probability here would be 1. It is certain that we're going to take a number from the union. Okay, question number 3. Find the lowest common multiple of 102 and 153. Now to do this, you could write out your 102 times table and also write out your 153 times table and get to a number that's in both lists. Here I'm going to do the prime factorisation method just to practice it because it will always work. So 102 is 51 multiplied by 2, And 51, now you might think that feels a little bit like a prime number, but it isn't. 51 is 17 multiplied by 3. We know it's in the 3 times table because when we add the digits together, 5 and 1, it makes 6. And if the digits add together to make a number in the 3 times table, then it is in the 3 times table itself. So 102 is 2 times 3 times 17. And 153, again, we can see that 1 add 5 add 3 is 9, and therefore it must be in the 3 times table. So this is 51 multiplied by 3, and we already saw that 51 was 17 times 3. So 153, if we were writing it the prime factorisation, 3 times 3 times 17. Now we're going to do our Venn diagram. So this circle's for 102 and this circle is for 153. And in the middle, we can put a 17 and a 3 in the intersection. And we're left with a 3 on the outside over here. And we're left with a 2 on the outside over here. If I asked you guys for the highest common factor, that would be the numbers in the middle multiplying together. So 17 times 3. So 17 times 3 would be 51. That would be the highest common factor, the biggest number that goes into both numbers. But we were asked for the lowest common multiple, which is the first number in both their times tables. And we're going to get that by multiplying the number in the intersection, that highest common factor 51, by any numbers that are left on the outside. So 51 times 2 times 3. So 51 times 2 is 102. Multiply that by 3 and we get 306. Just squeezed it in. There we go. 306 for that one. Question number 4. There are only pink cubes, grey cubes and white cubes in a box. The table shows the probability of taking at random each colour of cube from the box. So we've got pink, which is X, grey, which is Y, and white, which is Y. The ratio X to Y is in the ratio 2 to 1. Work out the value of Y. So they're saying that this probability here is double this probability here. So it's probably easiest if we just write this as 2Y. We're saying that that is double the probability of grey or white. Now altogether, 4Y we know needs to equal 1 because I've got 2Y, add Y, add Y. Always these probabilities need to add up to make 1. So 4y equals 1, which means that y equals a quarter or 0.25. And if y is 0.25, then x would be 0.5, and we would have 0.5, 0.25, 0.25. So there we go. That's our value of y. 0.25 is our answer for that one. Question number 5. It takes 5 workers 15 days to build a house extension. How long would it take 3 workers to build the same extension? And this is an example of worded proportion. In this case, the number of workers, if we have more workers, it's actually going to take less time. And if I have less workers, it's actually going to take more time. So we need to make sure that we're going the right way. Direct proportion would be something like if I buy 1 chocolate bar, it costs £1, 2 chocolate bars, £2, 3 chocolate bars, £3, and so on. Direct, they're both going to go up. In this case, as we get more workers, it's going to take less time. So 5 workers is 15 days. It's always a good idea with these questions to say, what about 1 worker? If I only had 1 worker coming to do the work, how long would it take? Well, with 5 times less people, if I've divided this side by 5, I would need to say it's going to take me 5 times longer. 15 multiplied by 5 is 75 days. But I haven't got 1 worker, I've actually got 3 workers. So let's then multiply that by 3. And if I'm multiplying the number of workers by 3, I'm going to divide the amount of time by 3. So that would be 25 days as our answer there. State one assumption you made in your working out your answer to part A. What we did was we assumed that none of these workers were lazy and that they all worked at the same rate. So that all workers worked at the same rate. Like I'm going to annoy people not writing on the line, but there we go. That's it. So ultimately, if one of them didn't work as quick as the others, it would slow you down. Question number 6. A rectangle has an area of 10 meters squared. Find the perimeter of the rectangle. So the height is 2 2/3. We don't have how wide it is, but we know that we can get that because base times height is going to give you the area. So I know that 2 2/3 multiplied by, let's call it the width, W, equals 10. And so to get the width of this rectangle, we're going to do 10 divided by 2 2/5. So 10 divided by 2 2/5. Now 2 2/5 as a top heavy fraction or an improper fraction, we do big multiplied by bottom, add on the top. So 2 times 3 is 6, add the 2, This is 8/3. And 10 divided by 8/3, we're going to change, flip. When we divide by a fraction, it's the same as multiplying by the reciprocal. So this is 30/8. If it helps, you can always make it 10/1. We're now going to work out the perimeter. I'm going to start by just adding the base and the height. So this is going to be 30/8 that we just worked out. Add 2 2/3, which again, I'm going to make top heavy. So that is 8/3. And to add fractions, we need to make the denominators the same. So let's make both of these out of 24 because both 8 and 3 go into 24. 24 is in the 8 and the 3 times table. Whatever we've done to the bottom of the fraction, we need to also do to the top, the numerator, to keep that fraction equivalent. I've multiplied the denominator by 3, so I'm also going to multiply the numerator by 3, and that's 90. For the second fraction, I've multiplied the bottom by 8, so I'm also going to multiply the numerator by 8, and that is 64. Adding them together, I get 154 out of 24. Now that simplifies because they're both in the 2 times table to be 77/12. How many 12s go into 77? We know that that fits in 6 times. 6 times 12 is 72. So it's going to be 6 wholes and 5 left over out of 12. Now we need to double this. Remember that we want to go all the way around our rectangle, and at the minute all we've worked out is these 2 sides. So to double this, I'm going to double the 6 and make it 12, and then I need to double 5/12. And here is where you need to be careful. If you double the 5 and you double the 12, you're not actually doubling it. You're just getting a equivalent fraction to 5/12. So to double it, we're just going to make it 10/12. So your answer here is 12 and 10/12, which you can simplify to be 12 and 5/6, as the final answer on the answer line. You didn't have to simplify it. It didn't say give your answer in its simplest form, but there we go. That would be your answer. Question number 7, and we're asked to complete the table of values for y equals 5 minus 2x. So to complete this, to get the y value, we need to take 5 and take away 2 lots of whatever the x value is. And we've got different x values that we need to work this out for. So when x is -1, I'm going to put -1 here. 2 lots of -1 is -2. So I'm doing 5 take away -2. And taking away a negative is going to add it on. 5 minus -2 is 7. Then I've got 5 minus 2 lots of 0, which is just going to be 5. Then I've got 5 minus 2 lots of 1, which is just going to be 3. And then the next one is 1, and the next one is -1. Each of these is a coordinate that we're going to plot on our graph, because each of these fits the equation and therefore lies on the line. So I've got -17, 0, 5, 1, 3, 2, 1, 3, -1, and we're going to join that up with a nice straight line going through all those points. And that is the graph y equals 5 minus 2x. Now I know 2 things about this graph. I know that it has a y-intercept of 5, that's the constant term, and I can see that there on the graph. And the number in front of the x, the coefficient of x, is -2. Therefore, our gradient would be -2. And that helps us out nicely when it comes to part C. Give the equation of a line parallel to y equals 5 minus 2x. If it's parallel, it needs to have the same gradient. So I'm going to go y equals 7 minus 2x. It's the -2 that needs to be in front of the x to make sure that this is parallel. You could write y equals -2x, add 5. No, not 5. 5 is the only number you can't use because then it wouldn't be parallel. It would just be the same line. Y equals -2x, add 4. Y equals -2x, add 1. Or y equals 9 minus 2x. All of these lines have gradients of -2 and all would be fine for that mark. Question number 8. The diameter of Jupiter is approximately 1.43 times 10 to the power of 5 kilometres, and the diameter of Mercury is approximately 5 times 10 to the power of 3 kilometres. Find the ratio of the diameter of Jupiter to the diameter of Mercury. Give your answer in the form n to 1. So let's put Jupiter on the left, 1.43 times 10 to the power of 5, and let's put Mercury on the right, so 5 times 10 to the power of 3. It has to be that way round because that's the order of the words in the question. Now I want the right-hand side to be 1. And to make that happen, I need to divide by 5 times 10 to the power of 3. If you've divided one side by 5 times 10 to the power of 3, we also need to divide the other side. So the question here that we need to do is 1.43 times 10 to the power of 5 divided by 5 times 10 to the power of 3. And we can do that by doing 1.43 divided by 5. 5 into 1 doesn't go. 5 into 14 goes twice, remainder 4. And 5 into 43 goes 8 times, carry the 3 over. So we've got 5 into 30, which is 6. So this is 0.286 times 10. Now, when we divide, we subtract the powers. So 10 to the power of 5 divided by 10 to the power of 3 is 10 to the power of 2. Now, I'm not completely happy with this because at the minute that number is not in standard form. If we want to make it in standard form, we're going to need to make the number on the left 10 times bigger, this bit, because the number has to be between 1 and 10 times 10 to the power of something. So we're going to make it 2.86. If you've made that bit 10 times bigger, you make the other bit 10 times smaller. So just times by 10 to the power of 1. It didn't say how you needed to leave your answer here. So if you left it like this, or if you did 28.6 to 1, either of those would be absolutely fine for the mark. Didn't tell you to leave it in standard form or not, and both of those are equivalent. 2.86 times 10 is the same as 28.6. Question number 9. ABCDE is a regular pentagon. HBF is a straight line and is parallel to GA. Work out the size of angle X. You must show all your working. So we've got a regular pentagon, and we know that angles in a pentagon, a 5-sided shape, add up to 540. I would really recommend just knowing that, going in and knowing that. Angles in a triangle add up to 180. Angles in a quadrilateral add up to 360. And every time you add a side, you add another 180 degrees. So it's good to know those ones. A hexagon is 720, or you can remember the formula, the number of sides, take away 2, times by 180. In this case, because it's a 5-sided shape, we would do 3 times 180, and that's how we're getting 540. Now, each angle inside that pentagon then is 540 divided by 5, and that is 108. So this angle is 108, this angle is 108, this angle is 108, and so on. Now, to get this angle here, we can see that angles on a straight line add up to 180. I've got 64, I've got 108, so let's work out what's missing. 108 add 64 is going to be 172. So I'm left with 8 degrees on the outside there. 180, take away 172 is 8 degrees. Then this angle, we know, will be co-interior. So if you have this shape like this, I know that those angles add together to make 180. So therefore this one would be 172. The angle X that we want is going to be what's left because angles around a point add up to 360. Let's do 172, add 108. That is going to be 280. And then let's do 360, take away that 280. More on the floor, borrow from next door, and that is 80 degrees. Doesn't look like 80 degrees, but bad drawing from me. Hopefully that makes sense that it's 80 degrees for that one. Question number 10. The frequency table gives information about the length of 50 parsnips. Find the class interval that contains the median. So the median is the middle number. If we have 50 parsnips, we always add 1 and divide by 2. So it's going to be between the 25th and the 26th parsnip that is our middle of this data. If you did 50 divided by 2 for this, got 25, you'd probably be okay as well. But technically, we should add 1 and divide by 2 to find the position of that middle. So you'd get 25.5 doing it like that. Where is that parsnip? There is a phrase I didn't think I'd say in filming this video. So we've got 2 parsnips in that first category. Then we've got 5 more. So far, we've had 7 parsnips. We've then got a further 15, and that takes us up to 22. So we've still not quite got to the middle parsnip. The middle parsnip is going to fall in that next category because after 20, we then go past the middle up to 42. So this is our answer, 15 to L to 20. For part B, on the grid, draw a frequency polygon for the information in the table. And this is where I get you guys to remember Polly the shark. So frequency polygon, you're going to remember Polly the shark like this. That's what it normally looks like. You are not drawing a bar chart for this. And frequency polygon, Polly the shark lives in the middle of the ocean. So you are going in the middle of the category. If the category is 0 to 5 and has a frequency of 2, we're going to go halfway between 0 and 5 and do our frequency of 2. So 2.5 across and 2 up. The next category goes from 5 to 10. So we're going to go across to 7.5, the midpoint, and up to our frequency, which was 5. We're then going to go up to 15, just there. Between 15 and 20, we're going to go up to 20. And then between 20 and 25, we're going up to 8. And that is there. You're joining this up with nice straight lines. Think about Polly's fin. It's coming up to a point. It might not always make exactly that fin shape, but it's a good way of remembering what that graph is going to look like. There we go. Question number 11. Simplify g to the power of minus 4 to the power of 3. A power of a power, we multiply those powers together. So this is g to the power of minus 12. For part B, I've got 17x cubed, y to the power of minus 2, multiplied by 3x, y to the power of minus 2. So 17 times 3 is 51. I feel like that's been a theme of this paper so far. X cubed times another x, that's the same as having x to the power of 1. X cubed multiplied by x is x to the power of 4. And then we've got y to the power of minus 2 times y to the power of minus 2. And when we times, we add the powers. We've just seen that. So minus 2 add minus 2 is minus 4. Adding a negative is going to subtract. So y to the power of minus 4 is your answer there. That was a 2-mark question. You would get 1 mark for 2 out of 3 things being correct. They're your 3 things. 1 mark for 2 of those being correct. Question C, work out the value. Now, as soon as I see work out the value, they want a numerical answer. So work out the value, what is this actually worth? Of 2 cubed times 2 to the power of minus 6 divided by 2 to the power of minus 2. When we multiply, we add the powers. So 3 add minus 6 is minus 3. And so we've got 2 to the power of minus 3 divided by 2 to the power of minus 2. And here, because we're dividing, we're going to take away the powers, which leaves me with minus 3 minus minus 2. And that's going to add it on. Minus 3 add 2 is minus 1. So the answer is 2 to the power of minus 1, but they wanted the value of this. And the value of this is going to be 1 over 2, a half, because we know that negative power does the reciprocal of the base, so 2 becomes a half. Okay, part D, and again, we've got a negative indice here. There are 3 things we need to do here. The negative power tells me to make the base number its reciprocal. I then need to root by the bottom, so the cube root, and then I need to do the power of the top, so the square root. So that 3 tells me to root, and that 2 tells me to square. So the cube root, because it's a 3, and then I'm going to square it. But first I'm going to get rid of the negative, and I'm going to do the reciprocal. So 27 over 64 to the power of 2/3 is my starting point. I've used up that negative by making the base number its reciprocal. I'm now going to cube root both numbers. The cube root of 27 is 3, the cube root of 64 is 4, and then I'm going to square it, and that is 9 over 16. So 2 marks for that one. Okay, question number 12, and we have a probability tree. The probability tree diagram shows the probabilities that Megan will be late for work on Monday and on Tuesday. Calculate the probability that Megan will be late on both days. So to do that, we're going to multiply along the branches that we want. If we wanted more than one pathway, we would add our answers together at the end. But since we are only interested in this pathway, we're just going to multiply those together. So 0.3 times 0.2. And I've included this very much intentionally because a lot of you will get this wrong. When we do 0.3 times 0.2, it is not 0.6, it is 0.06. So that's what needs to go on the answer line for that one. That was the only pathway we were interested in. If that's not making sense, think about the fact that 0.3 times 2 would be 0.6. And so if we're multiplying by 0.2, it's going to be 10 times smaller, 0.06. Okay, question number 13. The frequency table gives information about the cost in pounds of 36 different products in an online store. On the grid, draw a cumulative frequency. So I've hedged my bets here. I've done a frequency polygon. I've done a cumulative frequency graph. I also think it's worth knowing that how to do a histogram, although I feel like it's less likely to come off a non-calculator, doesn't mean it won't. But with a histogram, it looks like a bar chart. You're drawing those bars, but it's the area of the bars that is the frequency. That's histograms. If you're not sure about histograms, go and look that up because I haven't put that on this paper. Doesn't mean it can't come up though. We've gone for cumulative frequency here. And doing cumulative frequency, if something accumulates, it builds up as it goes along. So that means that we need to take the frequency and we need to add it up as we go down. Now, sometimes they do that for you and sometimes they don't. Here, I've not done it for you, so we're going to do it. So 0 to 5 has a frequency of 2. 0 to 10, the next category, we need to add that 6 on. So that takes us up to 8. Now 0 to 15 takes us up to 18. We're going to add on the 10. 0 to 20, we're going to add on the 12. That takes us up to 30. 0 to 25, we're going to add on the 5, and that's 35. And then 0 to 30, all the way to the top, add that on, and we get 36. So there we go, it's added up to 36, which I'm happy with because it told me in the question that there were 36 different products. So I'm happy it adds up to 36. Now with cumulative frequency, it's going to be an S curve. And because we've added it up to 10, up to 15, up to 20, at the top of these categories, we're going to use the top of the categories when we plot this. So poly the shark, frequency polygon, you're plotting in the middle. Cumulative frequency, you're plotting at the top. So up to 5 is 2. Up to 10 is 8. Can you see this? No, you can't. Up to 10, we got 8. Up to 15 is 18. Up to 20, we get 30. Up to 25, we get 35. And up to 30, we have 36. So let's plot that there. We're then going to join these points up with a nice smooth curve. So different to our frequency polygon, we want to join this up with a nice smooth S curve, like that. If you join it to the origin or if you don't join it to the origin, it actually doesn't matter for these questions. That's fine to do it either way. Use the graph to find an estimate for the interquartile range. Now the interquartile range is the upper quartile, take away the lower quartile. But let's start by finding the median. If there are 36 pieces of data, your median is going to be found by reading across at 18. On a graph, we just go halfway. So at 18, we go across, hit that and go down, I get the median to be 15. Your lower quartile is halfway between the median and the bottom of the data. So if we read across at 18 for our median, we'd be reading across at 9 for the lower quartile. And that gets me that value here. Now be careful with the scale here. I'm going to put that as 11. 11, 12, 13, 14, 15. Yes, I'm going to say that's 11. So the lower quartile, we do upper quartile, take away lower quartile, and the lower quartile is 11. You might be slightly different, and that's okay. There will be a small range of answers available for this, as long as you've read across at the right value. Now, we went 9 from the bottom, so we're also going to now go 9 between the median and the top of the data. So 9 bigger than 18 is 27. So let's read across at 27, hit the graph, and go down. And I get that to be 19. So 19, take away 11, gives me an interquartile range of 8. Question number 14. Write 0.135 recurring as a fraction in its simplest form. So to do this, we're going to let x equal 0.1353535, and I'm going to put dot, dot, dot. Now you need to either put dot, 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 or put the recurring dots over there. If you don't do that, you're going to lose a final mark on this question. It's really important that you show the examiner you understand that this number goes on forever. I'm now going to multiply this by 100 because I want to line the 3's up back under the 3's and the 5's up back under the 5's. So if I do 100x, because there are 2 digits repeating, it's going to move it over twice and I'm going to get 13 point. I find it really helpful to line that up, so make sure you do that. 13.5353535, and again I'm going to put dot, dot, dot to show that I understand that this goes on forever. You could have done 10x and 1000x, that would have been absolutely fine. I personally just like to do it this way because it's a little bit quicker. I'm now going to do the bottom row, take away the top row. Now everything beyond that point is going to cancel. 3 take 3, 5 take 5, 3 take 3 is all going to be gone. So all of those infinite numbers are going to be gone, but I'm left with 99x, because I'm doing the bottom take away 1x, take away the top, and 13.5 take away 0.1 is 13.4. I want to know what x is as a fraction, and to get that I can divide both sides by 99. So 13.4 over 99 is the same as, I wouldn't want to leave a decimal point in my fraction, 134 over 990. Now, both of these numbers are divisible by 2. Half of 134, well, half of 130 is 65, add on 2, so 67. And half of 990, half of 1,000 is 500. So this is going to be 10 less, so 5 less once you half it, so 495. That is our final answer there. Question number 15. 3 flapjacks and 5 brownies have a total cost of £16.35, and 4 flapjacks and 1 brownie have a total cost of £7.35. Work out the difference between the cost of a flapjack and the cost of a brownie. So I'm going to put 3F add 5B equals 16.35, and 4F add 1B equals 7.35. And now it might look a little bit more familiar as simultaneous equations. To be able to solve simultaneous equations, we want to make either the numbers in front of the F or the numbers in front of the B the same. And here I think it's easier if we just multiply this bottom equation by 5 to make them both 5B. If we know the cost of 5 brownies is the same in both, then the difference is going to be the cost of the flapjacks, and then we can work out that cost. So let's start by doing £7.35 multiplied by 5. 5 times 5 is 25, 5 times 3 is 15, add the 2 is 17, and 5 times 7 is 35, add the 1. So £36.75. So I now know that 3 flapjacks and 5 brownies is £16.35. We didn't change that one at all. But the bottom row, the bottom equation, we've now multiplied by 5. So 20 flapjacks add 5 brownies is £36.75. So the difference here is going to be the extra 17 flapjacks. So let's now do the bottom row, take away the top row. So 17 flapjacks, because I'm doing 20, take away 3. And now let's do £36.75, take away £16.35. And that's going to be 5 take 5 is 0, 7 take 3 is 4, 6 take 6 is 0, and 3 take 1 is 2. So £20.40. I now need to do £20.40 divided by 17 to get the cost of 1 flapjack. 17 into 20 goes once, remainder 3. 17 into 34 goes twice, and then 17 into 0 is 0. So the cost of 1 flapjack, 1F, is £1.20. And we can then substitute that back in to work out the cost of a brownie. So we know that 4 flapjacks, which would be £4.80, add 1 brownie is £7.35. So the difference in those costs must be the cost of our brownie. So let's now do £7.35, take away £4.80, 5 take 0 is 5, 3 take 8, more on the floor, borrow from next door, 13 take 8 is 5, and 6 take 4 is 2. So the cost of your brownie is £2.55. However, I asked you, what was the difference in those costs? So last step is going to be £2.55 minus £1.20. 5 take 0 is 5, 5 take 2 is 3, and 2 take 1 is 1. So your final answer, the difference between the cost of a flapjack and the cost of a brownie, is £1.35. Question number 16. Work out the exact length of AD. Let's put an X there so we know what side it is that we're working out. Now, Edexcel love to do this where they'll give you 2 triangles. They'll give you enough information in one triangle to give you a shared side, and then you can work out more information in the triangle that you're interested in. So we're going to start with triangle ABC, and I've got 2 sides and the angle in between, so this feels perfect for the cosine rule. So I'm going to do 8 squared, add 2 squared, minus 2 times 8 times 2 times cos 60, and that's a squared. And you're given the formula for that in the front of the exam. A squared equals b squared plus c squared minus 2bc cos a. That is in the front of your on your formula sheet. So let's simplify that down. A squared equals 64, add 4 minus 32, and cos 60 we know is a half. So I will do something at the end about how to remember your exact values, but cos 60 is a half. So 32 times a half is going to be 16. So we've got 68, take away 16, which is 52. And if a squared is 52, then a is going to be root 52. And let's just leave it as that, and we can say that that side up there is root 52. Great. Now we're looking and we have a pair. We have a side and an angle that are opposite each other. And when that happens, it tells us that we can use the sine rule. We can use that pair to get the other pair. So I'm now going to use the sine rule to get a side. So it's going to be A over sine A equals B over sine B. And again, you're given that in the front of the exam. So root 52 over sine 45, really important that your pair goes together, equals X over sine 30. And again, we've got some exact values at play here. So sine 45, you might know it as root 2 over 2. You might know it as 1 over root 2. Either way, if we're let's use root 2 over 2. If you know it as 1 over root 2, then you're just rationalising it to get it as root 2 over 2. They're the same thing. So I'm doing, let's go down here, root 52 divided by root 2 over 2. That's my first side. And then on the other side, I've got X divided by sine 30. And we know that sine 30 is a half. So this is what we're now working out. And to divide by a fraction, we know we multiply by the reciprocal. So this is multiplying by 2 over root 2. So root 52 divided by root 2, because we can divide by the bottom, this is 2 root 26 on the left, equals, now if X is being divided by a half, it's the same as doubling it. Dividing by a half is the same as multiplying by 2, so 2x. So therefore root 26 is X, and that is the answer going on the answer line. Root 26 for that one, but a very, very tricky question. Now the way I remember my exact values is I remember these two triangles. 1, 2, root 3, 60 and 30. And then I remember 1, 1, root 2, 90, 45 and 45. And that might seem like a lot to remember, but actually it's not, because you can use Pythagoras to work out the sides if you forget them. 1, 2, root 3. 2 is bigger than root 3, so 2 is the hypotenuse. And then down there we've got the isosceles triangle. 1, 1, root 2. 1 squared add 1 squared is 2. Square root of 2 is the hypotenuse there. And that one's isosceles, so 45 and 45. Now, if you can remember those, you can work out sine, cos, tan for any of those values. For example, let's just show how we got cos 60. So if I'm wanting cos 60, I need to imagine that I'm stood there. And we know that cos is the adjacent over the hypotenuse. So the adjacent 1 over the hypotenuse 2, cos 60 is 1 over 2, a half. I just use those to help me. Hopefully that's helpful for you to remember those. But I know lots of people have lots of different methods. So if you've got a method and it works for you, stick with it. Okay, question number 17. Y is directly proportional to x squared. When y is 8, x is 2. X is directly proportional to z. When x is 5, z is 10. Find a formula for y in terms of z. Give your answer in its simplest form. So let's start with y is directly proportional to x squared. When things are directly proportional, we just write them on one line. When it's inversely proportional, that's when you're using that fraction. So I always say we can't solve equations with fish in them. And we need to change that fish, that proportionality symbol, to be an equals and a k. These numbers are not the same, but they're linked somehow. So if we want to use an equals, we're going to have to say they're 2 times bigger or 3 times bigger or whatever connects them. And they will always give you a pair of numbers so you can work out that connecting value k. In this case, they've told us that when y is 8, x is 2. So 8 equals k times 2 squared. So 8 is k times 4. Dividing both sides by 4 tells us that 2 is k. We go back to the second thing we wrote, and we now know that y is 2x squared, and that is our formula connecting y and x. Now let's have a look at the second one. X is directly proportional to z. Can't solve equations with fish in them, so x equals kz. Now technically it would be a different k, but as long as you know that, it's okay to use it. I mean, yeah. Maybe use L, maybe use M, I don't know. But it's a different connecting factor. So I now know that X is 5 when Z is 10. And dividing both sides by 10 means that K is a half. Going back to the second thing you wrote, X equals a half Z. And we now have a formula connecting Y with X and a formula connecting X with Z. But they asked me for a formula connecting Y with z, y in terms of z. So I need it to be y equals some stuff. And that's going to happen if I take the half z that I know is x and put it in here. So it's going to be 2 lots of a half z and all of that is being squared because the x is being squared and x is half z, so half z is being squared. When we square a fraction, we are multiplying it by itself, so 1 times 1 is 1, 2 times 2 is 4, so this is 2 lots of a quarter z squared, and that's why they've asked us to simplify it. They, like I didn't write the question, 2 times a quarter is a half. So this is z squared over 2 or a half z squared. Either of those would be absolutely fine. So y equals z squared over 2 or a half z squared. Whichever one of those you wrote is absolutely fine. Question number 18. Show that 2 minus x plus 1 over x minus 5 divided by x minus x squared over x squared minus 6x add 5 simplifies to this, where a and b are integers. Okay, so let's start by worrying about these big square brackets. And remember, with algebraic fractions, you want to factorise everything you can. I'm also going to keep change flip here. We know that when we divide by a fraction, it's the same as multiplying by the reciprocal. So I'm going to flip it. And this is going to be x, 1 minus x on the denominator. And on the numerator, this is now this. It's going to be x and x. We're multiplying to make 5, positive 5, but we're adding to make minus 6. And that's going to be minus 1 and minus 5. Now that's a little bit annoying. I don't know if you guys have noticed, but I've got x minus 1 on the top. I've got 1 minus x on the bottom. So actually, if I'd have taken minus x outside the bracket, we'd have those signs the other way around and I could then cancel it. So let's do that. Let's change this. And instead of having x on the outside, I'm going to take minus x on the outside. I'm factorising this. Bring it down here. So if I write it the other way around, minus x squared add x. Hopefully this will show you how we can factorise this slightly differently to help us. So I'm going to bring minus x outside, and it will then be x minus 1. And now it matches up. So I can divide through by x minus 1. And because this is multiplying, I can just treat it as one big numerator and one big denominator. So I can divide by x minus 5 as well. And we're left with 2 minus x add 1 over minus x. Now, to be able to subtract these fractions, our denominators need to be the same. So I'm going to make this 2, so minus 2x over minus x add 1 over minus x. And to do that, all I've done is I've multiplied the top and the bottom of this fraction by minus x. Now they're both out of minus x. And now I can go ahead and subtract, but remember you're taking away both of these things. So it's going to be minus 2x minus x, which is minus 3x, and minus 1, which is minus 1, all over minus x. And let's just sort that out. Everything is negative here, so let's make it positive by timesing the top and the bottom by minus 1, and we get 3x add 1 over x. It asked me to write it in that format, so I'm happy with that. Ax add b over x, and we've got 3x add 1 over x. There we go. Question number 19. The graph of the curve of equation y equals f of x is given by the equation y equals 3x squared minus 6x minus 5. Find the coordinates of a turning point of the curve. You must show all your working. So here we are completing the square, but completing the square is always tricky when you've got a coefficient greater than 1, a number greater than 1, in front of the x squared. So I'm going to factorise that out. 3x squared minus 2x minus 5. I just like to factorise the first 2 terms. I find it easier. You can factorise all 3 terms if you want to. You'd end up with 5 over 3. You bring it back in, it's okay. I personally just like to do that. I always recommend doing that step. Now we're going to complete the square, on that bit. So this is 3. Use your square bracket so that you don't have to worry about it. We're now going to complete the square. To complete the square, we half the minus 2, so x minus 1 all squared. And we know that if we squared that bracket, it would give us x squared minus 1x minus 1x. So it would give us the minus 2x that we wanted, but it would also give us a plus 1 from the minus 1 times the minus 1. And I don't want that. So we take away the 1. Always take away this number squared. Great. Let's now bring that 3 back in. It's 3 lots of x minus 1 squared minus 3. And then we're just taking away 5 afterwards. So that's 3 lots of x minus 1 squared minus 8. Now the turning point is whatever value of x makes your bracket equal 0. So that's going to be 1. And then whatever number is here, the constant term on the end. So that is minus 8. Our turning point for this is 1 minus 8. Hence or otherwise, state the coordinates of a turning point of the curve y equals f of x add 2. What does this do to our graph? So we know that from transformations of functions, anything inside the bracket is going to affect your x direction, and inside the bracket does the opposite of what you'd think. So you'd think that this would go right 2, but actually x add 2 inside the bracket goes left 2. So I need to take the coordinate 1 minus 8, move it 2 points to the left, so minus 1 minus 8. If it was f of x add 2, that would go up 2, because outside the bracket affects the y direction and does what you would think. Plus 2 feels like it should go up, right? So there we go, just a little bit of transformations of functions for you as well. And last but not least, question number 20. Here are two similar cones. R to L is 1 to 3 and R to H is 1 to 4. Find H to L. Give your answer in its simplest form. So if R to L is in the ratio 1 to 3, I'm going to call this X and I'm going to call this 3X. And then R to H is in the ratio 1 to 4. So if R is X, I'm going to call H 4X. So I'm just kind of putting that information up there. Now we're asked to find H to L. So H is this one here and L is this one here. I don't have either of those lengths, but I was told in the question that these two things were similar. So it makes sense to try and get a scale factor here, but I don't have two things that are the same. What I can do though is make this into a right angled triangle to get the height. And we can use Pythagoras to do that. So looking at that right angled triangle, if I know the hypotenuse is 3x and the radius is x and I want this side here, I'm going to do 3x squared, take away x squared. But remember, that's going to be 3x all squared, take away x squared. So 9x squared, take away x squared is 8x squared. And we then need to square root that. So that is the square root of 8x. And that is my height here, root 8x. I now have two heights. I know that the height of the bigger cone is 4x. I know that the height of the smaller cone is root 8x. So now I can get the scale factor. I know that the linear scale factor is root 8 to 4. And you might want to make that 2 root 2 to 4. And you might then want to simplify it and write that as root 2 to 2. Great. So if I want to times from the small cone to the big cone, I'm going to go this way. And I would need to do big divided by small. So 2 divided by root 2. We would times by 2 over root 2 to go that way, and we would divide by 2 over root 2 to go that way between the lines, okay? The next thing we need to work out is capital L. So what I'm going to do here to get that is I'm going to take the 3x and I'm going to multiply it by our scale factor. So 3x multiplied by 2 over root 2, that was our scale factor, is 6x over root 2. I'm going to rationalise it though, and I'm going to make it 6 root 2 over 2x. L was 3x, and that one was 6 root 2 over 2, which is 3 root 2. So I now know this one is 3 root 2. If you simplify that down, divide it by 2, you get 3 root 2. So that is now 3 root 2. And the final part of this is to find the ratio h to capital L. So root 8x to 3 root 2x, we can lose the x's for the ratio. Root 8 to 3 root 2 is 2 root 2 to 3 root 2, which gives you the ratio 2 to 3. That was root 8. A lot of surds, a bit of similar shapes. Hopefully that made sense. Quite tricky, that one, wasn't it? That was not written by me, that was written by First Class Maths. So full respect to him for that last question. I really enjoyed that one. That was really good. He sent it to me and I thought, yeah, I've absolutely got to put that on there. So yeah, thank you for that one, First Class Maths. If you haven't done First Class Maths' predicted papers, then go and do them. They are amazing. Great, I hope you enjoyed the paper. 80 marks, some really difficult questions in there. So hopefully you followed along and you were able to enjoy it. Thank you so much for being here and I will see you on the next one.